Okay, so this is on your own, problem 11.9, dealing with boiling point elevation. So whenever you mix a solute into a solvent, you're going to raise the point at which that solvent will boil. So there's an exact calculation to figure out how much you will raise the temperature to make it boil. So that's what we're going to figure out right now. So whenever you have a boiling point problem, you do the same as a freezing point depression problem. Step one, you always find the moles of solute first. So if you look at your problem, they gave you grams of calcium carbonate. So you have to take grams of calcium carbonate, because that's the solute, and you have to turn it into moles of calcium carbonate, which you know how to do. So watching my significant figures, I need 3, I need 4, so I'm sticking with 3. I've got 3 significant digits, and I've got moles of calcium carbonate. The second thing I need to do is to take that and find the molality, because I need the concentration in the delta T part of my equation. So I'm going to find the molality, the little m, by taking the moles of the solute, which I now have, and I'm going to divide that by the kilograms of the solvent. Now I believe they gave me the solvent in grams. The solvent is acetic acid. So you had to change kilograms to grams. So there we go. I changed it for you. You had to change that to grams. So this should just say grams. Making sure you keep all your significant digits, keep all the zeros so you don't lose anything. So then I divide moles of calcium carbonate by grams of acetic acid. And I get a molality of 1.00. I need 3 significant digits. Then in step 3, I have to find I. I is the number that tells me how this molecule broke up. Calcium carbonate is my solute. It happens to be ionic. If it's ionic, you have to figure out how it will break up. If it's covalent, like the last problem we did, then it's always 1. This is not covalent, so we'll break it apart. It would break apart into calcium, which would be 1, and carbonate, which would be 1. So that gives you an I value of 2. Now I just plug the values into my equation. Delta T, I times the Kb, the boiling point, and then the molality. So I take 2 for my I, and I plug in the Kb value, which they gave me for acetic acid, and then I plug in my molality of this, this solution that I made. This is the concentration. So then I get that the change in temperature will be 5.86 degrees Celsius. Well, so then you go, well, what does that mean? Well, what that means is they told you that the normal boiling point of acetic acid was 118.1 degrees Celsius. Well, you have to add your delta T to that, which you decided that it would be raised 5.86 degrees Celsius based on what we did in our calculation. And that comes out to be 124.0 degrees Celsius. So what that means is, and I underlined the tenths place because I wanted to make sure you knew, because we're adding, we have to take it to the least precise place value. So that would be the tenths place. And so you end up having to round this up from like 123.86 or something to 124.0 degrees Celsius. So what that means is if I add calcium, this much calcium carbonate to this much acetic acid, then it's going to raise my boiling point from 118.1 degrees Celsius to 124.0 degrees Celsius. So this solution won't boil until it gets to a temperature of 124.0 degrees Celsius because I added calcium carbonate to it. So that's it.